And here we are in the lab again, and this is episode number 12 of Build Your Own MainBrain Microcontroller project. And last time we talked about parallel interfacing. This time we're going to talk about serial interfacing. There's a lot of serial interfaces out there. There's like USB, SATA, RS-232, RS-488, SPI, CAN bus. It goes on and on. But today we're going to talk specifically about I2C interface because MainBrain's display has capacitive touch, and that controller that handles the capacitive touch of the display sends information back and forth to the MainBrain's microcontroller via I2C bus. So that is what we're going to talk about, and it's a fairly simple interface with built-in commands. So you have to configure the controller in MainBrain, and then you send commands to the controller in the display, and you configure it, reset it, and can set it into a specific mode by sending commands and data to it over I2C bus. So I2C bus has two lines. One's the clock and one's the data. And so the data is transferred half duplex, since it goes only on one line and one direction at a time. All right. So let's take a look at the I2C specification to get warmed up. Okay, I2C bus has two lines, a data line and a clock. The data is SDA, and the clock line is called SCL. And the concept is that you have a master and X number of slaves on the bus, and each slave is addressed using 7 or sometimes 10-bit addresses. Each one is unique. No slave can transmit any data onto the bus until the master requests it. And so here's an example of an I2C bus implementation. Now the two lines, the data and the clock, is pulled up by two pull-up resistors. Now the way it works is the bus is never driven high by any of the devices. It's just released. So when the data bus is released, then it's just floats, except for the pull-up resistor pulls it high. So they have a MOSFET inside that's connected to an input buffer so that it can be bidirectional. So when you're controlling the bus, putting data on the bus, then you're pulling the data line low and releasing it. And 0 is low, and when you release it, that's a 1. And so for every clock pulse, there's one data bit transmitted or received. All right, so that's the basic idea of I2C bus. So it's a 2-wire serial communication, half duplex, that uses one data line to send and receive data, and then it has a clock pulse, and for every clock pulse there is one data bit transmitted or received. And the master is in control of the bus. Nothing happens without the master dictating it, and it has to have two pull-up resistors, one for the data line and one for the clock line to pull it up. And when you write data, you're only pulling the line low for a 0 and releasing it for a 1. So it's a fairly simple implementation. So let's take a look and see how it is implemented on MainBrain. for the touch screen. So let's take a look at the schematic. Here we are, the MainBrain schematic. This is the interface right here for the display touch. So it has several lines, but it has the SCL and SCA for the I2C. So that's where data comes in and out. Then it has the power supply. And then it has an interrupt. So when you touch the screen, it sends this line. It activates this line to tell the microcontroller that there's been a touch. And then the microcontroller can request what kind of touch and all that through the I2C bus. And then there's a reset so that you can reset the touch controller. All right. So let's start with the reset first. And that is controlled just by a port pin, RB13. All right. So we just bit bang that. And then we have the interrupt, and it comes in on interrupt 0 for the microcontroller. All right. And so then we have the SDA and the SCL. So let's do SCL. See, it has the pull up. We use 2K pull ups on MainBrain. So the SCL goes into the SCL for the second I2C controller. I believe there's 5 total on the chip, but we only use this. SCL2 and SCA2. So if we go to SCA here, or SDA, sorry, SDA2. All right. So it's the only I2C controller we implement on the microcontroller for MainBrain. And the touch screen is the only slave device or any other device, period, that is connected to the I2C2 bus. All right. So that's the only I2C device and technically the only serial device in MainBrain. All right. And so that's pretty much the way it's implemented in MainBrain physically. So let's take a look at the data sheet for the controller and see a little bit more about how to set up the I2C bus, the I2C controller. Okay, so the I2C protocol is fairly simple. You issue a start and then you send an address, and then the slave either acknowledges it or it doesn't. And then you send some data, and when you're done, you send the stop command. And that's pretty much it, really. An acknowledge from the slave is, it's either acknowledges it or it doesn't, and that's a NAC, an N acknowledged, the non-acknowledgement. And so let's take a look at the protocol data sheet. Okay, so this is the protocol. This is an example from Texas Instruments on the I2C protocol. So like I was saying, it begins with a start condition, and that is basically the controller, the master, pulls the SDA line, the data line low, and then pulls the SCL low. And this indicates that the device is claiming the bus, and all other devices on the bus can't communicate. They have to wait. All right. So then this is the way it works for a start. And then when it's done, it issues a stop. So it releases the SDA. And is it the SDA first? Releases high. Oh, all right. Yeah. So I think the SCL goes first, goes high, and then the SDA goes high. It's kind of a reverse. All right, and then ones are just releasing the bus during a clock or before a clock, and then if you pull it low, that's the low. Nothing complex there. And so it's clocked. Every one clock pulse is one data bit. And so this is the way the address works. So first it issues a start, sends out a 7-bit address, and it gets an acknowledge back, or it gets a knack where it stays high. And then it sends the data, and every byte is acknowledged. And the controller handles that. All right. It lets you know if it's an acknowledge or a knack. So it just goes in and tells it different things. It's pretty much what we just discussed. There's nothing really complicated about it other than maybe the timing and the way the logic works. But that's all taken care of inside the controller. All right, and then the data sheet goes on down, gives you an example of using a DAC with it. And I'll let you guys continue on with that if you want. Okay, so it's a pretty simple protocol. So now that we know that it's just a start and a stop, and then you get a knack or an ACK from the slave, and the controller, the module handles most of that. So let's take a look at how it's actually implemented in code. Okay, here is our driver functions for the module itself. It is in the file touch.c because this file handles the I2C low-level stuff and the focal tech controller for the touch screen, and anything else we need to do with the touch screen is all in this touch.c file. All right, so we'll come down here, and down here towards the bottom we have our driver stuff. And so it starts out with I2C wait for idle. So this function makes sure the bus is ready so that we can transmit, and it waits until it's ready. Okay. So if the bus, one problem with this is if the bus never got ready, this would never terminate. But in our case, the way the touch screen controller works and the way it's configured on MainBrain, there isn't that problem. But you should consider when you write the code that that could be a problem in some implementations. It could happen. All right, so, or there could be like some kind of error too, but anyway. So it basically just waits for some of the bits in the control register of the I2C module in the microcontroller. It just waits for some of them to become ready, and then it waits for, once they're ready, then the status, it checks the status in the status register of the module, and when it becomes ready, then it terminates, and then your program can start sending and receiving data. So then you would probably want to send a start. But when you send a start condition, the way I have it here, you check for it to be, the bus to be idle anyway, right? So you would probably want this to terminate your start condition if it was not idle. But this works great for the touch screen the way I have it implemented. So just keep that in mind. If you want to write code, you have to take in consideration that might be specific to your particular slave. But anyway, we have an I2C start. It checks for the bus to be idle, and then it sets this bit in the control register, which means to send a start condition. sets it to 1, and then while it's sending, it stays 1. And once it's completed with its cycle, then it goes to 0, and the function terminates. And you can go to the next one. And it's the same thing with the stop. It just sends a different bit. It just sets a different bit in the control register, and it sends a stop, right? And there's a restart, and the restart condition is so after you send a stop, then you can gain the bus right away without having to wait for another master or slave to. You can hog the bus basically, and so that's what happens with this one. It's the same as a start, except it just makes sure that you start right away after your last stop. All right. And then this is the acknowledge. So if something is controlling you, you want to send an acknowledge, and the same thing here, send an ACK. And it just sets control bits in the control register. And so then we just have our master interrupt handler and our slave interrupt handler. All right. And it just, nothing happens here. It just clears the flags here. I don't use those. All right, but you can if you desire. All right, so that's all it is for I2C. It's very simple. And then for like an example of implementation, this is the touch controller, and this is a function to read 16 bytes from the device. And so you send a start, and you send some data, and you wait for an idle, and you wait for acknowledge, send some more data, blah, blah, blah. And you're just building off of these functions, these low-level functions. All right. So using these low-level functions, you should be able to communicate with any slave on the I2C bus. Okay, so let's take a look at the configuration for the module itself. So that's done when we load all the initialization routines. We call the I2C initialize. All right. And then, so this is specific to the touch controller stuff. The only thing to be concerned about for the I2C specifically is these two pins. These are your clock and data pins on your microcontroller. So we just set those as inputs. That way the digital I/O doesn't interfere with the module. And so we set the baud rate. We have to use the baud rate. And so this 69 hex, with the way the clock is implemented in the microcontroller in MainBrain, this is a 400 kilohertz frequency baud rate. So we're transmitting at 400 kilohertz. All right. So you need to set that up. You got your I2C interrupt, and so that's enabled, and you clear the flag. Then we have the master and the slave interrupts, but like I showed you before, it's not implemented. And then that's the interrupt for the touch controller. So this is a hold time bit that's in the control register. So as you can see, there's bit 19 of the control register is this hold time, and it has a note, and it says it's not available on all devices. So you have to check to make sure it's in your specific microcontroller if you're not using the same one I am. All right, but it's just a minimum of 300 nanoseconds hold time on the data after the falling edge of the clock, and this is required to support SM bus. So SM bus is a system monitoring bus for like motherboards to communicate with lower level hardware devices, and it's not really applicable to our application, but maybe you will be working with that. It's hard to say. So you have to keep that in mind too, that it runs a little slower, has that requires that 300 nanosecond hold time. So if you're not using SM bus, then it doesn't really matter. The minimum, if it's 0, which is default, is 100 nanosecond hold time, which is faster. So apparently SM bus is slower. And then we have PCIe. That's a stop condition interrupt enable. So this will generate an interrupt in the module if there is a stop condition. All right. And then this enables the module right here. Turns it on. And that's pretty much all the configuration specific to the I2C controller inside the microcontroller itself. And then it just does some other stuff for the touch, which we'll cover later. But that's it for the I2C initialization. Okay, that's pretty much I2C or I2C bus protocol. And that's how I use it in MainBrain, and it's used for the touch screen to communicate data back and forth, touch data, and we'll get into the actual focal tech controller and the display controller, and we have to cover the backlight of the display. So that's coming down the pipe. But that's I2C in a nutshell, and I will see you in the next video.